Imagine closing your eyes and feeling a profound sense of connection and overwhelming peace that seems to link you to something greater than yourself. In that moment, your heart may race, your skin may tingle, and your mind drifts beyond the ordinary. What if I told you that this transcendent experience has a home in your brain? Today, on Sci Discovery Chronicles, we journey into the hidden circuitry of faith itself, exploring how recent neuroscientific discoveries are unmasking the brain's God spot and revealing that our capacity for spiritual experience may be wired into our biology. From ancient shamanic rituals to modern-day meditation practices, spirituality has been a universal thread in human history. Across continents and cultures, people have sought out altered states of consciousness through prayer, chanting, fasting, dance, and more, seeking answers to life's greatest mysteries. For millennia, these experiences were deemed mystical or divine. But in the last few decades, advances in brain imaging and electrophysiology have allowed scientists to peer inside the living human brain, observing the regions that flicker to life during moments of awe, transcendence, and unity. Early pioneers in neurotheology, an emerging field at the crossroads of neuroscience and religious studies, began by scanning the brains of monks and nuns during deep meditation. Functional MRI and PET scans revealed a striking pattern: decreased activity in the parietal lobes, areas responsible for orienting our sense of self in space. As this region quieted, practitioners reported a loss of the boundaries between themselves and the world around them, a neural basis for the sense of oneness often described in spiritual texts. At the same time, the prefrontal cortex, long associated with attention, planning, and decision-making, lit up with focused intensity. This dual pattern suggests that spiritual states involve both an inward turn of attention and a suspension of the ego's usual seat of power. Such findings have been replicated not only in Buddhist practitioners but also in Christian contemplatives and Sufi mystics, hinting at a shared neural melody across belief systems. Delving deeper, researchers examined the limbic system, the ancient emotional brain that governs fear, pleasure, and social bonding. Here, the periaqueductal gray, nestled in the brainstem, played a surprising role. Originally studied for its involvement in pain modulation and defensive behaviors, this region also activates during profound spiritual experiences, suggesting that transcendence can co-opt primitive survival circuits to produce euphoria and a sense of sacred awe. Equally fascinating is the involvement of the nucleus accumbens, the brain's pleasure hub. When individuals reported mystical bliss or the warm glow of communal worship, this reward center surged with dopamine release, the same neurotransmitter that floods our system when we taste chocolate, listen to music, or fall in love. Spiritual practices, it seems, tap into the brain's built-in reward pathways, reinforcing behaviors that connect us with others and foster cooperation, a key advantage for social species like our own. But what about the chemical messengers that set the stage for these moments? Serotonin, often studied in the context of mood and depression, also plays a critical role. Psychedelic compounds such as psilocybin and LSD, known to induce profound spiritual experiences, mimic serotonin at specific receptor sites, temporarily reshaping neural networks and creating heightened mystical awareness. Controlled clinical studies have shown that a single guided psilocybin session can yield life-changing experiences of unity and meaning, with neural correlates matching those seen in long-term meditators. These findings hint at a shared pharmacological pathway for natural and induced spiritual states. As we map these regions and chemicals, a new question emerges: are we evolutionarily hardwired for faith? Anthropological evidence suggests that ritual, myth, and belief conferred survival benefits, strengthening group cohesion, reducing anxiety, and enhancing cooperation. From an evolutionary standpoint, neural circuits fostering transcendence may have offered a selective advantage, weaving spirituality into the very fabric of human culture. Today, as we face global challenges and a crisis of meaning, understanding the brain's spiritual circuitry offers insights into resilience, well-being, and our quest for connection. Of course, science does not diminish the sacredness of spiritual experience. It illuminates its roots in our biology and underscores the marvel of consciousness itself. Recognizing that the same neurons that process sensory data and execute physical actions also generate awe and wonder invites us to revere the brain not only as an organ but as the very seat of the soul. In this exploration, we've traced circuits from the prefrontal cortex to the parietal lobes, from the limbic system to the brainstem, and from dopamine-fueled reward centers to serotonin-mediated networks. We've witnessed how ancient rituals and modern neuroimaging converge to reveal the architecture of transcendence. And we've contemplated the profound implications that our capacity for faith may be written in our genes, sculpted by evolution, and accessible to anyone who seeks moments of deeper connection. As you reflect on these discoveries, consider this: the next time you feel a surge of wonder-standing beneath a starry sky, swaying in a cathedral, or stilling your breath in meditation, you are experiencing the dance of neurons that has shaped humanity for millennia. We are, quite literally, hardwired for the divine. Thank you for joining us on this cerebral journey through the neuroscience of faith. If this exploration stirred your curiosity, please subscribe to Sci Discovery Chronicles, like and share this video, and leave a comment with your own experiences of spiritual moments. Until next time, may your quest for understanding be as boundless as the brain itself.